And here we are. Welcome everybody. This is SIG API Machinery for Kubernetes open source. Today we are on the month of July. The day is 9, 2025. And we have a couple of items in our agenda, so let's get to them. Thank you for the people that put them. Is that your name? Is that how I call you? Min.
Hey, can you hear me? Yeah.
Yes, can I hear you? Okay,
Just
Min. I forgot you were Min. Okay, very good. Do you want to take it over? Do you want me to present anything?
uh, if you can you open the
I
link to
can.
the data? Yeah, just I just hope to discuss about this pull request. It's about it's a kind of a very straightforward drop-in optimization for real FIFO specifically. I originally I tried to make these changes for Delta FIFO, but I just noticed that we're going to replace that Delta FIFO with real FIFO, so I just made the changes directly over there. And so overall, the point is to improve the optimization, improve the throughput for real FIFO of more generally more for controllers in a larger scale clusters. Um, so um, I can start with the issue the actual root cause we're trying to address. Can you click into the issue right there? Right. Yeah, so when we're trying to run the controller for larger clusters with, for example, 50K nodes or 100K nodes, and we're seeing sometimes the controller started to crash because of auto memory issues, and with our debugging and with our heap dump analysis, we found out that this is actually happening due to a lock contention issue. By that I mean um, so overall this real FIFO or delta FIFO is working as a single threaded loop. So it's popping the watch event from a queue in a single thread loop. So and there's multiple consumers. It's working in parallel, trying to pull requests, trying to pull the items from another queue, and that's essentially how controller works. So there's an issue when we're trying to list the object from the informer cache within the controller handler. So in that case, imagine we have a large list in a endpoint slice controller or daemon stack controller. I think there's a few controllers having this issue. So whenever we're trying to pull a long list from the informer cache, the read log of informer cache will be occupied for some time, and the contender of that log, that informer cache log, is this real FIFO log. So the issue, this slowness, this auto memory issue really happens because there's only one thread writing items to the informer cache, while there's multiple readers to the informer cache. So whenever, because it's a single thread loop, there's always an error gap. Imagine we have a for loop, right? The for loop and we occupied lock in that for loop. When the as the for loop iterates, there's always an error, quote unquote, error gap between each for iteration. So during the error gap, there can be multiple readers occupying the lock. So when the reader is taking much longer time than the writer, so uh we'll see this issue because um, um when there are too many watch events accumulating in the queue, then we found that the real FIFO cannot process the watch events efficiently. So did I get this issue clear? Or I can share my screen um to show you some.
It's a long conversation. I don't know if there is any part that you want me to go specifically, but the issue, I mean.
That that's the issue you're showing right now.
Yeah.
You know?
It's probably most important to see whether there's someone else who is able to review who also is hitting this problem versus going through the solution.
Mm-hmm.
So like I haven't hit this throughput problem. I don't know if Joe or Stefan or Jordan.
It wasn't on my radar. When I looked at it, it was certainly interesting, especially the boost at very high scale. But we don't actually, as far as I know, I don't actually have um, an instance of this happening.
Um, that's interesting because we're trying to, so we had this fix, well, quote unquote fix, because we verified that with these changes the auto memory issue no longer happens in a KCM controller, and that's so and based on our heap dump, when those auto memory issue happens, it's because too many requests like piling up in the real FIFO, and we can tell that from some trace logs. You know, when there's some slowness happening in the real FIFO or delta FIFO, we output a trace log, which also prints the overall the depth of the queue, and based on that trace log, we saw that there's over almost 1 million watch events in that queue. So yeah, that's interesting because we see this issue multiple times in some of our cluster. Uh, that that it's know that this issue only happens to those controllers having a long list. For example, let's say we have 1 million or 10 million pods in under a namespace, and inside let's say we have a controller inside the reconcile handler, we're trying to list all the pods inside that namespace. So when we do that list from the informer cache, the read log will be occupied for a long time, and that will slow down the FIFO process because in the FIFO we're attempting to uh, acquire the right lock.
So the reason why I say it's useful to try to find someone else who's an improver who has the problem is it's not going to, at least for me, it's not going to be an easy review. It's going to be, it's a pretty dense 300 or however many lines.
Mm-hmm.
And I'm not sure when I would be able to get to it. It would probably be a while.
Gotcha. So I also write a unit test that's able to kind of simulate this issue. If you can, if you whenever you any of you have time, you can just copy paste the unit test and run this in a Go playground.
This one?
Sorry, go ahead.
Is this one the test, or is something else that you want to show?
Oh, there's a link in the description of the pull request. Um, yeah, that just link, right? Um, it's just simulating. It's generating a lot of watch events and sending that to a fake watch channel. And meanwhile, we just run a controller, a simulated controller that's listing things um, from the informer. So yeah. Anyway, this is the an issue we observed in a larger scale cluster. It mostly happens to just um endpoint slice controller as well as a daemon set controller. But we had some other fixes to we had some other optimizations that's already merged to alleviate this issue. It works by adding some indexer what's that indexes to the based on the controller UID, the owner object controller UID. So but this I think this change, this proposed change is going to be a very straightforward drop-in optimization. Yeah, I think that's it. Yeah, so I think I can paste more data if you
I don't think it's the data. I think it's who and when would they find time to do the review. I would say that it's a fairly intricate thing to attempt to review. I don't know. Did you peek at the implementation, Joe?
No, I just haven't had the time. I was able to just kind of gloss over the high level. I really do appreciate the analysis here. And, based on what I'm seeing, this looks like a very interesting optimization with a lot of potential. But I'm kind of in a similar boat. I'm 2 weeks out from the main Kubernetes release, and I'm already taking on more review load than I was planning to for that. And so at this point, it's really hard for me to pick up something else. After that, there could be more time, but in the next 2 weeks, I'm pretty slammed.
Yeah, that's that sounds good. So I can rip on this whenever you have time, maybe later, a few months later, or um, yeah, but
Great. Yeah, no, I really do appreciate all the analysis here. I think this is a really interesting optimization. The numbers, I think, speak for themselves.
right, thank you. I think that's it for my
So, mean you are just to be clear, you're okay if potentially this doesn't merge into 134 or 134 was your goal?
Yeah, we're okay with that. We also because we have some internal patching mechanism, but this is something I feel as more and more users like having larger scale clusters for AI machine learning cases, this might happen.
Okay.
Or
But I think that helps a lot, for people like David and Joe that get a lot of, speaking of backlog, for by the time that code freezes come for each release. So if we are not time constrained, to make it happen in the next 2 weeks or something, then potentially, there could be more time for analysis and a better review. So that's great.
yeah, definitely. Yeah,
Yeah.
for sure.
Also, for the group, I would be very open to having somebody go in in front of me and look at this, try and poke holes in it, try and do whatever review you can before I have a chance to get to it. Having additional eyes on it before I get to it is certainly welcome. So, if anybody's willing to volunteer for that, that would be super helpful.
+1. That's great. Thank you, Min, for coming to the meeting. Let's follow up, after code freeze. Very good. That was our main topic today. I don't want to hold everybody here. Everybody can get more time back, but I just wanted to put on the screen very quickly what we are tracking for 134. Hold on, I have a single computer today and only one screen. So this is, as far as I can tell, what is officially tracked under SIG API Machinery for 134. Again, I don't want to hold, people here hostage and go one by one and have a discussion on each. Joe, David, if you think that is anything that we should, dig in from this list, or in general, people can take a look and we can continue offline.
I think number 9 is actually tracking pretty well. It says at risk. I'm just looking at the ones that say at risk because I think that's probably the most interesting thing. So I think it's the second column.
Okay, sorry. Yeah, thank you.
So I actually think number 9 is doing reasonably well. I need to think through everything that needs to happen there. But I reviewed something from Eric today. I'm going to review something tomorrow. So the other ones I'm seeing here at risk are 1 and 2.
Just to add an extra information, so currently the one marked as at risk only means the code hasn't been merged before code freeze. Yeah, so
Okay. I was
that's
wondering where this status was coming from. Yes. Okay.
yeah, for all the tracked ones, that means the code already merged.
Yeah.
Just a
Yeah,
reference.
hang on. Declarative validation still has outstanding.
Yeah, that's
Well, I won't.
it's
I
not
won't lead on.
progressing, but yes.
Yeah.
Maybe that's the distinction, but yes, that's actually the one I'm most actively tracking really closely right now. I think mutated emission policy, we've got almost everything in. Number 2, I know that there's a couple PRs out that I haven't gotten to review yet. That's watch list. So I was planning to get to those today, and then I'll kind of have a sense on whether or not that I feel that's at risk. I think mostly what we're trying to do is turn a bunch of things off. And then consistent read some cache, I actually wasn't aware of what's going on there. So look at that. Is there anything else anybody wants to flag from this list?
Number 4 is actually deferred.
Yes, that's on the read path, and the performance numbers were like what 50x below what we wanted them to be, and we didn't feel like we could figure that out in the time allotted, so we're going to defer that.
Sounds good.
Okay.
So I wanted to bring visibility to what's going on 2 weeks before code freeze. Let's see. Okay. Well, it was a short, productive meeting. Thank you, everybody. And I will upload the recording later today. And let's continue the conversation in Slack. Thank you so much for coming. Have a good Wednesday.